Hi everybody, I've had a request to work through question 3 of the level 2 2018 NCEA electricity paper. This is the circuit diagram, and question 1 was to calculate the total resistance of the circuit. So you have this lamp in series and those two are in parallel. That's how you calculate the total resistance. So it is 7 plus, and in parallel we got 4.80 to the power of -1 plus 7 to the power of -1, close brackets, -1, 2.85. So it's 7 plus 2.85, and you get 9.85 ohms, which is nearly 10 ohms. Okay, and then part B said, so part B was calculate the voltages across bulbs 1 and 2. So that's part B, voltages across bulbs 1 and 2. So in order to calculate the voltages across bulbs 1 and 2, I need to find circuit current. So circuit current is voltage, which is 12 volts, divided by total resistance. And when I do that, so it's 12 divided by 9.85, always use unrounded numbers. So I get 1.22 amps, it's 1.21875. Okay. And then, so that's a current. So the voltage across bulb 1 is current times resistance. So it's 1.22 times 7. So I multiply that by 7, I get 8.53 volts, and then the remaining voltage is what's the voltage across that. So voltage across lamp bulb 2 is 12 volts minus 8.53. So 12 minus 8.53 will give me 3.47 volts. So that's the voltage across the bulbs. And then the next part of the question is, both these bulbs are not the same brightness, and it says discuss which bulb is brighter and why. So that's the question. So the reason why they're not the same brightness is brightness depends on the power output, and power depends on voltage and current. So yes, they both have the same voltages across them, which is 3.47 volts. However, because they have different resistances, the one with the lower, the bulb with the lower resistance will have a greater current through it. So, and power is current times voltage. So this bulb, which has a lower resistance, will actually be the brighter bulb, okay? Because they've got the same voltage, but if the current is bigger, the one with the bigger current will have the bigger power output and therefore the brighter bulb. Now the last part, I think this is what really the question was. So what actually happens, this is the last part. So an ideal emitter, that means that emitter doesn't have any resistance. So an ideal emitter is added like this. Okay, it's added in parallel to the circuit over here. What is the effect, or discuss the effect of adding the emitter on the current, the voltage, and hence the brightness of each bulb. So what actually happens is when you add the emitter of no resistance, what we have to keep in mind is that current always takes the path of least resistance. So what's going to happen is current is going to take this route, it's going to come like this, and then it's going to go through here, and it's never going to go through bulb 1, and then it's going to split into 2, and then the current is going to follow that path. So I've just kind of traced it in green. So what happens is when you have that emitter here, there's not going to be any current through it, so no voltage, so the bulb is not going to glow, bulb 1, okay? However, the size of the current is now going to change, because the effective resistance now, instead of 9.85 ohms, is only going to be 2.85 ohms. And so it's just these two together in parallel. So because effective resistance has decreased, the current from the source is going to increase. And because the current from the source is going to increase, this bulb over here is going to have a larger proportion of the current because its resistance is less. So this is going to be even brighter than before. This will also glow but not as brightly, and it's possible for you to calculate the value of the current, which is 12 divided by 2.85. You're going to get an answer. And then you can also find, so the voltages across each of them will be now 12 volts. So bigger voltage, bigger current, and through each of them proportionally, but that one will be brighter. So I hope that made sense. Bye for now.